the next example, it says find the magnitude just means size, of A, where A is equal to 2I minus j plus 4k, and hence find the unit vector A. So the magnitude of A is just going to be, you've learned how to do this in 12.1, and this is another way of writing magnitude of A. So you just put that in a modulus form, modulus sign. So you've got 2 squared plus minus 1 squared plus 4 squared square root, and that gives you root 21. So unit vector, the definition of unit vector is that it's A over the size of A, or the magnitude of A. So A itself is 2I minus j plus 4k, and you're going to put root 21 in the denominator, and that is it. Okay, that's how you write unit vectors. You've learned that in book 1 as well. Next, now here you're going to learn something different. You're going to learn angle of angle between vectors. So it says if the vector A is equal to xi plus yj plus zk, and if this makes an angle theta x with the positive x-axis, then cos theta x is equal to x over mod A. And similarly for angle between y, it's obviously going to be y over A, and for z it'll be z over mod A. Okay, so example that would be if A is 2I minus 3j minus k, it says find the angles that 2I minus 3j minus k makes with each of the axes to one decimal place. So first things first, find the magnitude of A. That's just 2 squared plus 3 squared plus 1 squared square root. Obviously it doesn't matter that they are negative, because when I square them they'll just become positive. And the magnitude is root 14. Okay, and then cos theta x will just be x over mod A. So the x component is 2. So I write 2 over mod, well, 2 over the size of A, which is root 14, and one decimal place, that is 0.5345. And if I do a cos inverse of that, then theta x will be 57.7 to one decimal place. Okay, now we'll repeat this for angle between y and angle between z, and if I did that I would get 143.34 angle between that vector and y coordinate axes, and theta z will be 105.5 degrees. Okay, and the working for this will be minus 3 over root 14. Do shift cos and you will get this answer. For theta z you will just do minus 1 over root 14, shift cos, and you will get this answer. Next example, it says the points A and B have position vectors. So A is 4I plus 2j plus 7k, and B is 3I plus 4j minus k. So the 2 points A and B have position vectors such relative to a fixed origin O. Find AB. find a b vector. So a b vector is just b minus a, which is 3, 4, minus 1, minus 4, 2, 7, and that's minus 1, 2, minus 8. Okay, so that's the AB vector. Then it says show that OAB is isosceles. So I have got to work out. So basically, imagine that this is my coordinate axes. Yes, it's 3D, okay? But it doesn't matter, I'm going to draw in 2D. This is O. Let's say this is A. Let's say this is B. Doesn't really matter where is what. But if I was to draw this triangle OAB, I just need to show that this is an isosceles triangle. And how can I do that? By showing that two lengths are equal. Okay, any of these two lengths, if they are equal, then the triangle that I have drawn is an isosceles triangle. So size of AB is 1 squared plus 2 squared plus 8 squared square root, and if I did that I would get root 69. The size of OA is 4 squared plus 2 squared plus 7 squared square root, and that gives me root 69 as well. I've already shown that two sides are equal, but I'm just gonna check OB as well, and that is 3 squared plus 4 squared plus 1 squared square root, and that gives me root 26. So I say triangle OAB is an isosceles triangle because AB is equal to OA.